All right, so now we're kind of looking at level 2 problems. So level 2 problems are going to be the fact that we have a radical here and it's equal to 2 terms. So our last problems, it was just one radical equals a number and we were able to square each side or cube each side. So it's going to be the same idea. You still want to get this radical term or those parentheses by itself, but you're going to have to do a little bit more. Now also with these problems, extraneous solutions can pop up. So an extraneous solution is a solution that does not work in the original equation, meaning when you plug it back in, you're going to get something like 5 equals negative 5, which is false. So if you get that, whatever solution you plugged in is going to be extraneous. It's not going to work. So my radical here is isolated. It's by itself. So to get rid of this radical, because it's a square root, I'm going to square this, which means I have to square this side. So what just popped up over here is the fact that I have to FOIL. So I'm going to write this out 2 times so I remember that I'm going to have to FOIL that together. When I square this square root, I end up with just 7x plus 15. So now I FOIL this and I have x squared plus x plus 1 again, and that's equal to 7x plus 15. Combine my like terms, x squared plus 2x plus 1 equals 7x plus 15. So you can see what's kind of developing here is the fact that we have a quadratic equation. So I'm going to subtract 7x. So x squared minus 5x plus 1 equals 15. Subtract my 15. So now I have to solve this equation. X squared minus 5x minus 14 equals 0. So I have to find numbers that multiply to be negative 14 and add up to be negative 5. So when I do that, I get x minus 7 and x plus 2. So this tells me that x could equal 7, it could equal negative 2, it could equal both of them, it could equal none of them. Okay, we're not quite sure. What we have to then do is now we have to check. So you have to take this 7 and you have to plug it back in. So 7 plus 1 equals the square root of 7 times 7 plus 15. So is 8 equal to the square root of 49 plus 15? Is 8 equal to the square root of 64? Okay, so yes, the square root of 64 is 8, so that does in fact work. Now, because this square root is printed on our paper, you only include the positive version. Okay, so 7 is an answer that works. Now I have to also check negative 2, sorry. So negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. So here I get negative 1 equals the square root of negative 14 plus 15. So negative 1 equals the square root of 1. Now again, because this is printed on our paper, we don't have a plus or minus. We did not take the square root, so we are not solving. We did not get plus or minus. This negative 1 equals positive 1 is what it's saying. That is a false statement. That's telling me that negative 2 is an extraneous answer. So you could end up with no solution for these problems. You could end up with 2 solutions. Don't automatically think that the positive one is going to work and the negative one's not going to work. That's not always true. So watch it, be careful. All right, so one more in this type of problem. We still want to get this parentheses by itself, so go ahead and subtract that 9 over. So I have 3x plus 21 to the 4/3 power equals 81. Now, same idea that we did before, where we want to get this to the 3/4 power now. Okay, because you want to multiply by that reciprocal. So I have the 3/4 power here. So now we can go ahead and change this to the 4th root of 81 to the 3rd power. And then I still have this 3x plus 21. Those cancel out. Now, because it's a 4th root, that means I'm going to need a plus or minus. So the 4th root of 81 is 3. So now I have the plus or minus 3 to the 3rd power. So I'm setting up 2 equations here. I'm going to have 3x plus 21 equals 3 to the 3rd, and I'm going to have 3x plus 21 equals negative 3 to the 3rd. So I end up with 3x plus 21 equals 27, and 3x plus 21 equals negative 27. Okay, so we're developing 2 answers here, and that's coming from the fact that we took a 4th root. That even index indicated we needed a plus or minus. So this gives me 3x equals 6, which means x is 2. This one gives me 3x equals negative 48, which means x is negative 16. Now, our directions are telling us to check for extraneous solutions, so you have to take these, you have to plug them back into the original equation. So if I take 2 and I plug it in here, now I end up with 6 plus 21 to the 4/3 equals 81 essentially, because we can subtract that over. So this becomes 27 to the 4/3 equals 81. Well, if you think about this radical, this is the cube root of 27 to the 4th power is 81. 3 to the 4th is 81. That does, in fact, check out. That's good. Okay, so this is telling me that 2 is a good answer. Check this one. 3 times negative 16 is going to be negative 48 plus 21 to the 4/3 power has to equal 81. So here I end up with negative 27 to the 4/3 power equals 81. Again, if we change that to the cube root of negative 27 to the 4th, is that going to equal 81? Well, the cube root of negative 27 is going to be negative 3. Now, this negative 3 is to the 4th power. So when we take that negative to the 4th power, yes, it is, in fact, going to be a positive 81. So we don't have an extraneous solution here. We have two good answers. One is 2 and one is negative 16. All right, that's video 2. Video 3 is going to have level 3 problems. We got 2 more to go through. Guys, you're doing a great job.